Although we can use roles to allow users or groups of users to access specific dimension members, that works well when we have a few groups that need to access the same set of dimension members. This process can quickly become unmanageable when we have a lot of members in a dimension and we want fine-grained control over the members that each user can access. Rather than set up a role for each possible combination of access that we need to support, we can use dynamic security. The first step in implementing dynamic security is to create a user dimension, assigning a user ID to each Windows login for which we want to control access. It's important that we create the table using the domain name and username for our Windows network in order for dynamic security to work correctly. The next step is to create a bridge table that maps each user to the dimension members that they can access. That way, we can simply add or remove rows in the table when we need to make changes rather than have to update the roles in the cube. We then need to update the data source view for our Analysis Services database to include these tables. These tables can be maintained in a standalone database or in the same database that contains the tables already in the data source view. It doesn't really matter. The most important thing is that our bridge table contains a column that we can join to a dimension table in our data source view. If we use a separate database, we'll need to remember to add a data source to define the connection to that database. With the tables in the data source view, we can then add the necessary database objects. For example, we need to set up a user dimension, which is very straightforward. It's just a single attribute. And then we set up a measure group for the bridge table using just a count measure. And after adding the dimension to the cube, we make sure we have the right relationships between the dimension that we want to secure and the new measure group. And we need to do the same between the user dimension and the new measure group. After we get everything set up correctly, we can hide the count measure and the user's dimension, but when we're first setting things up, we might leave them visible so that we can create queries more easily and test our security settings. Our last step is to create a role and define the allowed member set using a dynamic expression. To create the dynamic expression, we use the non-empty function to find the intersection of dimension members with the current user. Specifically, we want the non-empty function to return the set of members, in this case state provinces, that match the members in the bridge table. In the demonstration, we'll see that we map users to specific state provinces and then define security on the state province attribute hierarchy, and so that would be the attribute hierarchy that we use as the first argument of the non-empty function. The second argument of the non-empty function has two parts. In technical terms, it's a tuple consisting of a member of the user dimension and the count from the measure group based on the bridge table. To get the right user dimension member, we use the username function, which returns the login for the current user. But that's a string value that we can't use directly in a tuple, so we concatenate that login with additional strings to conform to the unique name format of the member in our user's dimension. At this point, it's still a string, so we use the string-to-member function to convert it to a member data type that we can use in a tuple with our measure. Effectively, what the non-empty function does is take each member of the state-province attribute hierarchy and combines it with the user and geography user count to see if there's a value at the intersection or not. When this value exists, the state-province member is returned by the non-empty function, and that means the user is allowed to see that member, along with all the others satisfying the same condition.